What if I told you that two planets in our own solar system, Venus and Pluto, suddenly exploded? It sounds like something straight out of a blockbuster sci-fi movie, right? But let's indulge this cosmic what-if for a moment. What would actually happen if these two vastly different worlds were instantly vaporized? Let's start with Venus, Earth's so-called twin. It's a hellscape of crushing pressure and scorching temperatures, wrapped in thick clouds of sulfuric acid. If Venus were to explode, the first thing we'd notice wouldn't be a giant fireball. Space is a vacuum, so there's no oxygen to fuel a traditional explosion. Instead, the planet's mass would be violently ejected outwards at incredible speeds. This colossal cloud of superheated rock, metal, and gas would expand rapidly into the solar system. Here on Earth, about 25 million miles away at its closest, we wouldn't be safe. The initial blast of light and radiation would be intense, but the real danger would come later. Depending on the orbits, a massive debris field would be heading our way. Think of it as an asteroid belt on steroids, a shotgun blast of Venusian shrapnel. The smaller bits would burn up in our atmosphere, creating a spectacular, terrifying, and constant meteor shower for years, maybe even centuries. Our night sky would be permanently streaked with light. But the larger pieces, the city-sized chunks of what was once Venus's crust and core, would pose an existential threat. A significant impact could trigger mass extinctions, dwarfing the one that wiped out the dinosaurs. It would create global firestorms, mega tsunamis, and plunge the Earth into a long, dark impact winter by throwing dust and soot into the atmosphere, blocking out the sun. Satellite communications, GPS, and space exploration would become nearly impossible, as the space around Earth would be a lethal minefield of debris. The gravitational balance of the inner solar system would also be thrown into chaos. Without Venus's pull, the orbits of Earth, Mercury, and Mars would be subtly but permanently altered. Over thousands of years, these changes could accumulate, potentially making Earth's orbit more elliptical. This would lead to extreme temperature swings, making parts of the year unbearably hot or freezing cold, and fundamentally changing our climate in ways we can't fully predict. The solar system would become a much more dangerous and unstable neighborhood. Now, let's turn our attention to the far-flung dwarf planet Pluto, over 3 billion miles away. Pluto is tiny, smaller than our own moon, and composed mostly of ice and rock. If Pluto exploded, the consequences for Earth would be far less direct, but still significant for our understanding of the cosmos. The explosion itself would be just as silent and violent as Venus's, a rapid expansion of its frozen material. The immediate effect for us, practically nothing. We wouldn't see it happen in real time. Light from Pluto takes over 5 hours to reach us, so we'd find out about its demise long after the fact, when our telescopes point to its position and find nothing. Or rather, a faint, expanding nebula of ice and dust where a world used to be. The debris from Pluto would be a huge problem for the outer solar system. It would create a new, diffuse ring of debris in the Kuiper Belt, the icy region beyond Neptune. This could increase the chances of comets and other icy bodies being knocked out of their stable orbits and sent hurtling towards the inner solar system, including Earth. So, while the immediate threat is low, the long-term risk of a comet storm decades or centuries down the line would increase. The biggest loss from Pluto's explosion would be scientific. We've only just begun to explore this distant world with the New Horizons mission, which revealed its heart-shaped glaciers, towering ice mountains, and thin nitrogen atmosphere. Losing Pluto would mean losing a treasure trove of information about the formation and evolution of our solar system. It's a key piece of the puzzle out there, and its destruction would leave a permanent gap in our cosmic knowledge. Now, what if, in some truly unbelievable cosmic catastrophe, both Venus and Pluto exploded at the same time? This would be the ultimate celestial nightmare. We'd be facing a two-front war. From one side, a wave of hot, rocky debris from Venus, threatening direct impact and orbital chaos. From the other, a long-term threat of icy comets being sent our way from the disrupted Kuiper Belt. The combined gravitational effects would be even more unpredictable. The solar system is a finely tuned machine, and removing two of its components, even one as small as Pluto, would have cascading effects. The orbits of all the other planets, asteroids, and comets would shift. Our beautiful, orderly solar system would become a chaotic shooting gallery. The night sky, filled with the constant streaks of Venus's remains and the occasional visiting comet from Pluto's legacy, would be a constant reminder of our precarious position in the universe. Life on Earth would be forever changed if it survived at all. We'd have to become a species hyper-focused on planetary defense, developing technology to track and destroy millions of incoming threats. Our view of the heavens would shift from one of wonder and exploration to one of fear and survival. Of course, the good news is that planets don't just spontaneously explode. There's no known natural process that could cause such an event. It would require an unimaginable amount of energy, far beyond anything that occurs naturally in a stable solar system like ours. So, while it's a terrifying thought experiment, you can sleep soundly tonight. Venus and Pluto are right where they should be. This journey into the hypothetical just goes to show how interconnected and fragile our cosmic home really is, and how lucky we are to live in a relatively peaceful corner of the galaxy. Thanks for watching and exploring this cosmic what-if with us. If you enjoyed this journey, be sure to hit that like button and subscribe for more deep dives into the mysteries of our universe.